also come. So we have waited a long time. Uh, okay, my student, I think that my sound is quite okay. My sound is quite okay, and my screen is also okay, isn't it? Isn't it?
Yes, sir.
Okay, my sound is okay. My screen is okay. Please, I'm muting you because of unnecessary noise. But if you face any difficulty, you can ask. You can definitely ask. So, my students, you all know that we are studying the different configurations of, the different configurations of bipolar junction transistor. At the very beginning, we have given you and we have come up with these main equations. So I'm just 2 minutes reminding that we have got a main equation that is IE equals to IC plus IB. Here E is emitter, C is collector, and B is base. Okay, so there are, we all know that the transistor is a three-terminal device by emitter, collector, and base. So in this three-terminal device, three currents. So from there, we have find out that the current of emitter is equal to the current of collector and the current of base. So this two current is summation is equals to IE. So it is a, it is true for all kind of configurations. So try to at least remind it that IE equals to IC plus IB. Okay. Finally, we saw that there is a current gain known as alpha, which is alpha equals to IC divided by IE, where IC is the collector current, IE is the emitter current. And we all know that, sir, the value of alpha is 0.95 to 0.98. So it is close to 1, not exactly 1. Okay. We also defined another current, current gain, that is beta, and it is IC by IB. And you know that the value of IB is so small, respect to C, IC, and IB. So we can easily tell that the value of beta will be much more bigger. So usually the value of beta is 50 to 400. 50 to 400. So you can understand that the base current is so small respect to collector current. Okay. He got two factor alpha, another one is beta, and we need to know what is the relation between these two. We can also know that the relation is alpha equals to beta divided by beta plus 1. And how we get this, we have also discussed, and it is available in the previous slide also. Okay. Another equation, that is VBE equals to, or almost equals to, 0.7 volts, which is also an important information because it means that VBE, that means base to emitter. Base to emitter voltage is 0.7 volts. Okay, base to emitter voltage is 0.7 volts. And another equation is IE equals to beta plus 1 IB. So how we get this? From this beta equation, beta is equals to IC by IB. We can easily get IC equals to beta IB. Just cross multiply and take this value from and put this value here, IC. If we put this value here, IC, it will be beta IB plus IB. If we take common IB, it will be beta plus 1. So IE equals to beta plus 1. So we get these equations from using these other two equations. Okay. So these are the important relations we need to know because otherwise we will face some problems. So after that, we saw fixed bias configuration. We are seeing different configurations. And my students, I'm not, showing you so many mathematics. Instead of showing you so many mathematics, I'm showing you different types so that, whether any type comes, you can, actually solve for that. And process is always same. The process is always same. You have to calculate in the input side and the output side using KVL. So process is always same. This was fixed bias configuration. We showed that how it works, Then we have an example of fixed bias configuration. Then the emitter bias configuration. Okay, emitter bias configuration in the last class we discussed. There is only one change, that is the resistance is available in the emitter side. We also discussed that how it solved. Then finally it comes to the voltage divider configuration, voltage divider bias. That means now the input voltage, that means the beta is now divided into two resistance for RB. Now RB is divided into two resistance. One is R1, another one is R2. And we for that we need to make the Thevenin circuit. We have to find out the Thevenin resistance and the Thevenin voltage. To replace these, finally something like that. The input side, we are applying E Thevenin and the R Thevenin. So I also discussed, if I'm not wrong, please tell me. But I remember that I discussed this Thevenin theorem and to all of you, and also showed you one example. So basically, I'm first of all I'm discussing the configurations, then I'm showing you an example. So that can help. That can help. Today, that is one of the important and interesting configurations, that is collector feedback configuration. So how the name comes from collector feedback. You see that my students, uh, probably you have studied feedback or not. Mm, Feedback is something, the some signal is taking from one side to another side. Suppose my students here IC is going, okay, this is the collector point. One value is coming from collector to input also. We all know that feedback is interesting thing. Here in this configuration, we all know that this base and emitter is the input side. The base and emitter is the input. And this collector and emitter is output side. So if you take some signal or your output signal or output current again to the input, that is called feedback. Feed means to feed, and back means to feed back or to flow back. So you see that there is one part or one electric connection is connected with here and with a resistance that is connected with the input. So you can see that from the output one current is flown to the input. That's why it is known as feedback. Always we know that from input it goes to output side, but now from output it is going on some part, it is going to input. That's why it is known as feedback. Okay. So here the change is that that the collective feedback, that is why, because we are taking the feedback from the collective side. That's why its name is collective feedback configuration. And also, my student, the resistance name is now RF, and the current will flow, that is absolutely ID. Okay. Interesting thing is here, my student, the current was IC till here, if the feedback was not given. But now the current is IC prime till here, because this is node. After that, the current is being dividing into two sections, one this side, another one is this side. So this IC prime will be not equal to IC, because this IC prime is the summation of IP and IC. But remember, the value of IB is so small, very, very small current, very, very small current. Okay, so that is the difference. So what can we do? Uh, still same, my student. We need to calculate the positive side, not the positive, the input side and the output side separately. That's the interesting thing. So, now here we can see that only one VCC. So we can consider this VCC, suppose it is connected here also, it is connected here also. It is both the same point, both the same point. So when we will calculate for the input side, at that time the VCC will be here, and this is the ground connection. So we will apply KVL where this VCC will be there, this resistance will be there, this resistance will be there. This base to emitter voltage will be there, and this emitter resistance will be there. So there will be 5 components where we'll calculate for the your input side KVL, because at that time it will be something like that. This way it will go. You know, this way it will. So let's go to the next slide where it is demonstrated to all of you. You see that now, student. Uh, you see that this BCC has been taken here, and it will calculating to this input loop. So everything is same. So you take BCC and the current will be here. So suppose I'm taking this positive, the second sign, that is plus BCC. That it will be minus RC I prime C. Then it will be IBRF. Then it will be minus VBE, and finally minus IERE. We will apply the KVL. Okay, the input sign. You see that now here, whatever I just told you, that this is our desired, that KVL equation. VCC minus ICRC minus IBRF minus VBE minus IERE. We need to find out, my students, we need to find out the IB. Okay, we need to find out the IB. So at that time, uh, we can easily, we have to replace. You see that there are 3 currents. One is IC prime, one is IB, one is IE. We always see that from the input side, we tend to collect current of IB. Okay, so we need to replace this IC prime, this IE. We need to replace. Interesting thing is that here, this IC prime is not exactly equal to IC, but still as you know that IB is too small, we can take this IC prime equals to IC equals to IC, and we also know that the IC is also close to equal IE if as the IB current is too small. So using these 2 configurations, using these 2 assumptions, we can replace those. We can replace those 2 current. You see that now here, the IC prime will also replace as IC, and IE will be also replaced by IC here. But we need IB, and we all know that beta equals to IC by IB. So definitely, if we represent IC using IB, it will be IC equals to beta IB. So basically, we need to give this IC equals to beta IB. You see that from here IC prime, it will be beta IB, and also this IB will be IB. Also this IERE, it will be also beta IBRC. RE, because we will first of all we will replace this IE using IC, then we will replace this IC using beta IB. So our main focus will be to represent the all current using IB. Okay, because from the input side we will collect tend to find the input current. So from this equation we can take the common of IB from one side. Okay, if we take the common of IB, then it will be something like that. It will be something like that. So we take all the IB terms on the other side, take the common, and finally divide by those all terms. So this finally we will find out this IB equals to BC minus BBE divided by RF plus beta RC plus RE. Okay, so this is a small calculation. If we just sum up all the IB terms and take that and take common the IB, and finally you just divide the 2 sides. So in this way, we will find out the value of IB. After finding out the value of IB, how to find out the value of IC? The value of IC will be easy. Just beta into IB. Beta into IB. This is very easy. Okay. Next, go to the collector emitter loop. So in the collector emitter loop, that means in the outer loop, now the VC is here. We can easily consider this. So if we apply, the KVL here, we can take the second sign. Suppose this one, it will be IERE plus. When you take the second sign, it will be plus VCE. We take the second sign. This is the current my I prime C RC, and also it will be the second sign. So that is a minus VCC equals to 0. Okay. So because we all know that, sir, we just that the IC prime equals to IC and IE is also equals to IC. Our assumption, because the current of IB is too small, so you replace this two current by IC. Finally, we take the common of IC, and we need to find out from the output side is that is the VEC, the output voltage, the voltage across collected to emitter, the VEC. So the VCE will be equals to the VCC minus IC RC plus RE. So very easy calculations, and also the repeated calculations. You know that in the previous 3-4 configurations we showed you, the process is also same. You can understand from the fixed bias configuration, from the emitter bias configuration, and also the voltage divider bias configuration. The the process is also same. So that's why I think that it will be not so tough for all of you. So this is the way of finding out the collector feedback configuration. So in this example, there are there are an example given here. So you see first that how to solve. My friends, I'm also telling you that this type of example, when it will come, you will apply the KVL in the positive side, that means in the not positive side, sorry, in the input side and in the output side separately. After that, you will get the equation. Don't try to memorize the equation, the big equation. You can memorize the small equation. Suppose IE equals to IC plus ID, or VE equals to 0.7 volts. It is small equations, but these big equations, they have different configurations. You don't need to memorize. What you need to apply the KVL. Okay, because you see that this is the IB current will flow. This here will be the IC prime current. Here will be the IC current. Here will be the IE current. Okay, so you can definitely apply the KVL in this loop and also the KVL here. Okay, so you apply KVL, you find out the equation IB, and then the equation VCE. If you find out IB, here is the beta is given here, beta equals to 90. You can easily find out the IC, because IC equals to beta into IB. So what I will do, I will go to the next slide and show you that how it is solved. So you see how it is solved by yourself, because here it is given here this equation. They have applied these two equations directly, but we just showed you that how we got these two equations. We applied a KVL in the input side, we applied a KVL in the output side. So from input side, we got the equation of IB. From output side, we got the equation of VCQ. That is the VCE, the output voltage, collector to emitter voltage. So they have given this equation directly. They have given this equation directly, but we will not apply the equation directly. Okay, what we will do, so we will apply KVL in the input side and output side. We will find out this equation in solving mathematical solving. So we don't need to find out the we don't need to memorize these equations in our head. So now I will tell you, my all students, open your pen and paper, solve this input side and output side, and find out the IB equation. You have the reference here, and also find out the value 11.91. All. I'm giving you 5 minutes, because every time I just discuss and you just see. Now you try for the IB. You apply the KVL equation in this side. Everyone, you open your paper, pen and paper, and apply these. This will be the 10 volt, and also drawing the circuit connected with the ground. Okay, this is the 10 volt. So you apply this KVL and find out the IB equation. It will be same, exactly same, and find out the value of IB is 11.91 microampere. I'm giving on 5 minutes. Now start solving.
Sir, in the input side, right?
The hour busy receiver.
My student, is it finished? I think that some of you have finished. If you finish, you can take your pictures of your page and give me to the messenger, our messenger group. I will see.
Okay, sir. Listen. But sir, the calculation it becomes same way.
Same?
Yes, sir. It becomes same way.
Yes, it will be same. It will be same.
Yeah, sir. Is it okay?
Mm, yes, it will be same. Exactly same.
Yeah,
Here,
like
11
this
point.
same way. As you can see, this same way.
I cannot see anything.
Oh, yes, sir. I'm sure you cannot see anything. But I'm talking about your design. Your screen share. See this screen share. The right panel. Right panel.
You will screen share.
No, sir. I'm not talking about that. I said it should be same way like your right banner.
Yes.
Okay.
Yes. Okay. After finding out the IB, my student, please, what I'm trying to say that I'm emphasizing that you practice because you see this kind of mathematics, but if you don't practice, uh, it will be not possible to help. So basically, that's why not possible. So that's why you practice in home to solve this one. You solve, your confidence will grow. Your confidence will grow up. Okay, let me. আচ্ছা বাংলাদেশি তোমাদের কি আছে মেজবা আছো মেজবা
জি স্যার, মেজবা আছে স্যার।
এই
না স্যার, মেজবা বের হয়ে গেছে মনে হয়।
না মেজবা আছে এখানে এখন।
আছে মেজবা আছে।
মেজবা আছো এই জিলহাস তোমার সাথে কি ফুয়াদের কথা আছে নাকি পরিচিত আছো
না স্যার, ফাদার সাথে তো কথা নাই, মেজবার স্যার সাথে আছে, মেজবার সাথে।
ফুয়াদ কিন্তু গ্রুপ লিভ দিছে
ও
আমাদের গ্রুপ লিভ দিছে সো
ঠিক আছে স্যার, আমি দেখবো নি স্যার, ফোন দিয়ে দেখি।
ঠিক আছে okay so we can easily find out the VCE also just apply KVL in the output loop side okay we'll find out these equations and just place this value easily we can find out the equation so what I'm trying to say that the configurations might be different but still if you apply the same way it will be easy my students now you see that these mathematics are exactly same just one thing is that so now the feedback resistance is 2 okay rf1 rf2 so don't get frightened no so instead of rf now there are two one is rf1 another one is rf2 so there will be no change instead the place of rf it will be rf1 plus rf2 okay so there is only change only one change let me see you that here suppose here in this
Sir, sir, right now, right now they're in series. How about if they're parallel?
sorry
And just they're in parallel, sir. They're connected in series. So how about if they're if they're connected in parallel?
if they're connected in parallel then at that time it will be totally different
Yes,
so
it should be R1 plus R2 divided by R1 times R2.
yeah. Suppose
Okay.
if you're talking about sir if they're connected in parallel at that time you can easily make the parallel into one equivalent resistance
Oh,
isn't it is it
yes, sir.
possible
Okay, got it. Yes, sir.
that is the thing in
Okay,
series
sir.
we can sum in the parallel you can definitely use the parallel equivalent resistance 1 by r1 plus 1 by r2 that's true okay
Yes,
so
sir. Thank
what
you.
I'm trying to say that you see that the rf in here the place is rf but in the next example in the place of rf it will be rf1 plus rf2 that is the difference you see that here it is also described here that instead of rb that means it will be rf1 plus rf2 So basically this was the RF. Okay, so here you see that these are the two resistance. Clear? So there is no except difference without this. So there are there are two resistance. The main resistance is now divided into two series. If it is connected parallel, then at that time you can easily make it one resistance just by 1 by R1 plus 1 by R2. Okay, easily you can make these also. Okay, so this type, this is also same way we have just finished. Nothing changed. The next is emitter follower configurations, or it is known as common collector. Common collector. Okay, common collector configuration. So set in the same way, my students, it will not change the KVL, the KCL, it will absolutely not change. So what I'm trying to say that now we have come in such a stage that we can solve. So what is emitter follower configuration? What is emitter common collector configuration? It is that we know that, sir, now the collector will be grounded. There are two conditions. One, if it is common base, the base will be grounded. If it is common emitter, the emitter is grounded. If it is common collector, the collector will be grounded. How can we see that this is collector, common collector? You see that this is the collector. The arrow side is emitter, the middle one is the base. So you see that the collector is connected with the ground. Okay. So the collector will be grounded, and the output will be taken from the emitter. You see that the output is taken from the emitter. This is the output point. Also, you see that the input is from now the base to collector, and output is emitter to collector. So you see that the collector is common. That's why it is known as common collector configuration or emitter follower configurations. Emitter follower configuration. So in the same way, we will apply in the here in the input side the KVL, the output side is also a KVL. You see that now we will not discuss too much because these are the same pattern. So if you apply the KVL here, what will be that? You see that here the IB current. So if you take the second sign, this will be plus minus IBRB, then it will be minus VBE. Finally, it will be minus IERE. Finally, there is a source is given here. You see that there is a source is given here, which is minus. That's why it will be minus side. It will be first, then the positive will be here. So it will be minus. It will be plus V. So the second sign is plus. So that's why the plus VE is 0. So from here we'll try to find out the IB, and we all know that's a IE equals to beta plus 1 IB. We replace this IE using this. Okay, so finally we find out what is the value of IB in this way, similar way. In a similar way, we apply the KVL in the output side. Also, we know that from here, we just apply the KVL. So this is the plus VCE. So the minus VCE, the minus IRE, and the the plus VE. Just to take the second sign. Take the second sign, and at the time it will be plus minus VCE. So take the second sign. So minus VCE minus IERE, and it will be plus VE. VE. From here, you can also find out the VCE equals to VEE minus IERE. So in the same way, you can find out the output voltage also. Okay. So probably there is an example is given here. So in the similar manner, we can find out the IB, VCE, and finally IE also. Okay. These are the equations. We just find out the IB equations, the VCE equations, and finally the IE equations. So now what I'm trying to say that my student that it's same way. The process is same, the KVL, but you need to find out the difference that the common collector, the common emitter, that all the before this, all the things we discussed that was common emitter, and we discussed several configurations, almost five configurations for common emitter. This is the common collector, and one is left, that is common base configurations. Okay, so it will be also same. We know that in the common base configurations, what is this? The common base configuration. We know that the base will be grounded.
On the ground, yes.
Yes, the input will be into emitter and
Emitter,
bias base, and the collector will
yes.
be the
Output,
output will be collector and base. Okay, so
yes.
in the similar manner, this is the emitter resistance, this is the collector resistance. So we can apply the KVL. We can apply the KVL and find out the different current and the voltage uh, equations. So let's see that what is given here. So first of all, they applied in the input side. They applied in the input side that in the input side they applied the KVL here. Easily, if they apply the KVL, they find these equations from here. They got now the input current is emitter current, not base current, my student, because the input is emitter to base and the base is to grounded. There is no resistance here, so the input current is emitter current. So we find out the IE from this equation easily. And now the interesting thing is that if we want to find out the IC, now sorry, the VCE, the VCE. Now, if we apply the KVL in the this side, will not get the voltage VCE. So to get the voltage VCE means this is the C, this is the E. So this voltage, okay. So we have to apply the KVL into the total loop. With the total loop, let me draw one more time. Into the total loop, total outer loop, we will apply the KVL, total outer loop, because at that time we will find out the output current, output voltage VCE, or not the output voltage. Now the it is the voltage of VCE. The output voltage is the VCB now. So to find out the VCE, we need to find out we need to apply the KVL to the total outer loop. So if we apply the KVL to the total outer loop, we'll find these equations. I'm not showing you, several times, because this is absolutely easier terms. If you just take second sign or first sign, you will get this. You will get this throughout. After that, here from here, we see that there are two currents, IE and IC. So we're talking about, we know that IC equals to IB. I'm sorry, IC equals to IE. So we just replace the IC by IE, something like that, because we have already find out the IE. So we replace the IC by IE. So we find out the equation of VCE. So to find out the output voltage VCB, we can now apply the KVL into the outer loop. Now we can apply the KVL into the outer loop here. So you see that they have applied the KVL here in the outer loop. If they apply the KVL, they get this equation. From this here, you can easily find out the VCB. So it's more or like same for all configurations, almost same. So there is an example given here, my student, which is also in the same way we find out basically we have to find out the current IE, the current IB. If we find out the IE current, we all know that IE equals to beta plus 1 IB. Here the beta value is also given here, so we can easily find out the IB also, and we can also find out the VCE by the applying the KVL in the outer loop, and by VCB just applying the KVL into the output section. Okay, so these are all the Kirchhoff voltage law again. So from here, so you can see that as first of all we find out the IE, and we all know that the IE equals to beta plus 1 IB. So we just divide by beta plus 1. Basically, the current is microampere. You see that the emitter current is 2.75 milliampere. The collector current is much more less, almost 61 times less. So then you apply the KVL in the outer loop. They have used the equations here directly because they have already shown you. So but you will not do like that. You will apply the KVL something the same way. So you'll find out this voltage, and finally to find out the voltage VCB, that means the output voltage here. Now the output is across the collector and base. Okay, and that is B and that is C. So we have to apply the KVL into this loop, into this outer loop. So at that time we will find out this tree value Here we will find out the BCD. So in this way we will solve. Okay, so I in this last two configurations I have not discussed too much because this is more or like same, my student. There is no not required to repeat the same thing again and again because the policy is already we got. That's why we need to find out the input loop and the output loop, and we need to apply the input loop. From input we will apply get the current. From output we can get the output voltage and also the current. Okay, so more or less it is exactly same. Okay, so now I will open to the floor to all my students. Not so many students are left, but still, is there any confusions you can ask?
No,
No, sir. No.
no
Because
confusion.
sir, all the questions is concerned about KVL and KCL, sir. No KVL only.
Not KCL.
Yes, only KVL, sir.
KVL,
Only KVL.
and there
Yes,
are
sir.
some basic equations. We all know that the IC, the alpha equations, the beta equations, the IE
Yes, yes,
equations.
sir.
These are equations we are discussing more or less almost 2 weeks. Almost two
Yes,
weeks.
sir.
So it is not so
Like
unfamiliar to us.
I see over BJT. Yes, sir. It is.
So is there
So
any
exactly.
questions, my student?
No, sir.
No, sir.
Okay. On that note, I will give you the 10 minutes break. After you can stay here, or you can join in the same link because I am not ending this link. My computer will be open. Okay.
Okay, sir.
Okay, sir.
Computer will be open. After that, I will take 30 minutes of lab. That means that how to connect this NPN transistor into the software. Okay, I will show that one or two. Then you can easily practice on your home also because I will just show you that
Okay,
how
Okay,
to
sir.
connect one. Then you can easily practice.
Okay, sir.
So I will give you 10. It will be 10:40. Please, I am not ending this session. You will join the same link using the same link. You can either
Okay, sir.
stay here or you can leave, no problem. But you will join in the same at 11:40. Okay.
Okay, sir.
Okay, sir.
Assalamu
Okay.
Well, go mesh ka ba? Malik mesh iga firaaqay oo kale. Kulli wax laaf ma. Kulli ku qomlo wala. Luki wixii oo bastadi bastone mu gool lixi qayb kale kusoo mar kale soo jeedin waana badanaa glass ku soo xaday Soomaaliya. Xasan Cabdullaahi ma ka baxay meesh baxsaf ma ka baxay Taleebaan ma ka baxay
adiga baxarsan Cabdiraxmaan
eh
adiga baxart
ana hadda bixir waay waqad
halkaa ka baxdo
Let me share the screen. So already, my God, half of the students have gone. Have they given the role? I'm afraid. Today I didn't say to give you a role. What about the chat box?
Yes, but
Assalamu alaikum, sir.
Sorry, salam. Okay. Okay, my student, probably they will join. Okay, let me wait for 1 minute. After that, in the meantime, go to the component mode.
okay, sir.
Component mode, go to the peak device P, and now we need a transistor. We write generic transistor with give me 30 seconds. Ma, ma. Okay. We need to, find out the transistor. We'll write generic transistor. TENERIC. Generic transistor. So we find out that generic NPN transistor. Okay. Then we need resistance also. So generic resistor, generic resistor symbol. We get this. So yeah, that too is enough for us. So first of all, we'll see that so the basic of that how is the emitter current and equals to the emitter current equals to the base current and the collector current. So we'll first of all check that. Okay, and if I show one type of configurations, you can easily connect when you are free in the home. So it's not so required. If I it's not required that I will show you every configuration. I will just show one, then you can easily connect in home and easily practice. So suppose let me connect 3 resistance into the emitter, collector, and base. 3
There is
resistance.
game class.
Sorry, 3 resistance. Okay, the base resistance should be big. Why? Because we need base current, small base current. So I'm making base resistance, suppose 50 kilo ohm. Suppose still if you don't change, it still work, but still the base current should be smaller current. Then we connect with the collector side, we connect with the emitter side, and then we connect with the base side. Okay. Now we need to connect these emitter, this collector and the base. Okay, one thing is left. I forgot to add, that is we want to see the current. So that's why we need ammeter. Okay, so we need ammeter. So we go to the oscilloscope, the instrument zone, we go to the DC ammeter, because we need ammeter to see the current going on. So we give 3 ammeter here, which we'll just use to see the current, what is the flowing current in the base, in the collector, and the emitter. Yeah, where okay, just connecting the 3 ammeter. Now we can connect with the ground and the voltage source. So we connected the emitter and the collector and the base is connected. We need a ground. We go to the terminal mode, find out the ground, place the ground. The emitter is grounded, and here we need what? We need a voltage source. Okay, we need a voltage source. We go to the generator mode. We go to the DC. Okay, we go to the DC and we apply a DC. But okay, let me change the name VCC, and suppose voltage is 20 volt. The biasing voltage is 20 volt. Suppose. Okay. So and one thing is left. The current will flow. That is not here is ampere. So it should be in the milliampere. The current it should be the milliampere. My God. Hassan, can you hear me? Hassan Abdullahi. Hassan Abdullahi. Hassan.
Yes.
So you change the ampere rating of this ammeter, and you then play. See that the ammeter current is 1.08 and the collector current is 0.17. The base current is 0.191. So from here you can see that the base current and the collector current is the summation of the emitter current. Okay. So what do we know? Absolutely. And here you can also see that the terminal voltage of different terminal voltage. And the next thing we want to try that we need to find out the voltage between this base and emitter. So we take DC voltmeter, place here, and place this point here and connect this point here. Okay, and then play. You see that the voltage is 78.78. That is the the base voltage that's connected here in the. So in this way we can easily connect different configurations of the in the different configurations of the transistor of the NPN transistor. You just connect with a different resistance according to the circuit, and you'll find out the current, the voltage, just connecting different ammeters and voltmeter. Okay. So let me find out the rows first. 30 batch roll 3, 29 batch roll 7, 30 batch roll 4, 30 batch roll 15, 29 batch roll 14, 29 batch roll 16, 30 batch roll 8, 29 batch roll 4, 30 batch roll 4.